This is a rates and accumulation problem, or a contextual problem. What we have is G of t, which is the rate at which unprocessed gravel arrives. We have that there's 500 tons of unprocessed gravel at time t equals 0. And we also have that the plant processes gravel at a rate of 100 tons per hour. The first question asks us to find G prime of 5 and interpret the answer. So G prime of 5, this is a calculator problem. So to take the derivative and plug in a number, then we're going to use the calculator. I have G stored into Y1. So then math 8, taking the derivative of the function that I have stored in Y1, evaluated at x equals 5, is this number. So negative 24.588, rounded to 3 places past the decimal. It would also be okay to take the derivative and plug in by hand, but with a calculator problem, it's just so much quicker and probably less chance of an error also to just let the calculator take the derivative and plug in. So if G of t is the rate at which unprocessed gravel arrives, then G prime is the rate at which the rate is changing. So the rate at which the rate of unprocessed gravel arriving changes. Which the rate of unprocessed gravel arriving changes. There's our noun. If G of t is a rate, then, and it tells us that G of t is tons per hour, so then the derivative of G of t is going to be tons per hour per hour. The units for G are tons per hour, the units of time are hours, so in tons per hour, or tons per hour squared, at t equals 5 hours. Noun, units, time. Part B, find the total amount of unprocessed gravel that arrived during the hours of operation. The way that we're going to turn the rate of unprocessed gravel arriving into the amount of unprocessed gravel that arrived is going to be to integrate the rate. So first fundamental theorem, integrating the rate of change of unprocessed gravel arriving gives us the amount of change that of unprocessed gravel that arrived. And we're going to use our calculator to integrate. So math 9, 0 to 8 of the function that is stored in Y1, integrated with respect to x. So 825.551. Part C says the amount of unprocessed gravel at the plant increasing or decreasing. What G of t is the rate in. That constant 100 is the rate out. It's like a water problem of water flowing in and water flowing out. It's just that unprocessed gravel is arriving as the water flowing in, and the rate at which that gravel is being processed is the rate at which the water is flowing out, if this were a water type problem. So in order for the amount of unprocessed gravel to be increasing, the rate in has to be greater than the rate out. And we're talking about at t equals 5, so we're going to find G of 5. We're going to use our calculator to find G of 5. We're going to take G, which is stored in Y1. We're going to evaluate it at t equals 5. We get this number, 98.141, which is less than 100. So G of 5, the rate at which the gravel is arriving, is less than the rate at which the gravel is being processed. Therefore, the amount of unprocessed gravel is decreasing. The rate in is less than the rate out. And then part D is going to be where most of the points are going to be. It says what's the maximum amount of unprocessed gravel. We're looking for an absolute max on a closed interval. So then that means we're going to be doing the candidates test. We're going to check our endpoints. And then we also need to find the critical points. The rate of change of the total amount is going to be the rate in minus the rate out. And if I'm going to find critical points, then I'm going to take that rate of change of the total amount. We're trying to find the max total amount. And so the critical values are going to be taking the rate of change of the total amount, setting that equal to 0. The rate of change of the total amount is the rate in minus the rate out. G of t is the rate in, and 100 is the rate out. So what we're really trying to find is where G of t is equal to 100. So then using my calculator, G of t is in y1, 100 is in y2, and my window, the time interval is from 0 to 8. If I'm trying to see where that function that I have stored in y1, G of t equals 100, then I'm going to look for a y min of 99 and a y max of 101, so that I see that y value that I'm interested in of 100. There's G of t. There's y equals 100. We're going to calculate the intersection. 1 point of intersection, enter, enter, enter. Here's the number that we're looking for, 4.923. The amount of gravel, unprocessed gravel, time t equals 0 is 500. To find the amount of unprocessed gravel at any time, we're going to need the initial amount plus the change in the total amount. The change in the total amount is when I integrate the rate of change of the total amount, which is integrating the rate in minus the rate out, from 0 to whatever time we're talking about. And so the first t value that we're going to plug in is 4.923. And then we're going to do the same thing with t equals 8. We're going to evaluate these two expressions using the calculator. Also keeping in mind that when we solve for something on the graph menu, then that value automatically gets stored to x. So 500 plus math 9, the integral from 0 to x of the function that I have stored in y1 minus 100. Or we could say the function that we have stored in y2, which is that constant 100. We get this number, 635.376, and we're going to evaluate the same expression, except this time with the upper limit being 8. And then we get this 525.551. We don't want to do that all that work and then not get the credit for this work. So then we also have to write a summary statement. That is our answer. The max amount of unprocessed gravel is 635.376 tons. I didn't check to see how the points were distributed here, so I'm not positive about this, but if I had to guess, I would say 1 point for g prime of 5, 1 point for the explanation, now in units and time, 1 point for the integral, that gives 825.551. Let's see what else points are given for here. 1 point for the integral, 1 point for this comparison, g of 5, probably 1 point for the explanation, and then 3 points for that last part, which is finding the critical value, a prime of t equals 0, the answer, and the justification. So 1 point here for a prime of t equal to 0, 1 point for the answer, and here the justification is going to be the work of filling in the table with the candidates test.